Here, our goal is to determine the size of angle A. Notice that we can often spot interior alternate angles by drawing a Z shape. And so let's draw a Z shape. Here, we have a Z shape, and this Z shape can help us to identify alternate angles. Indeed, the alternate angles are 55 degrees and A. These two angles are alternate angles. Notice we have the Z, and these two angles are alternate angles, or we could say alternate interior angles. But what do we know about alternate interior angles, or what do we know about alternate angles? Notice, according to this chart, we have the Z shape, and this angle, those are alternate angles. And notice that this is A and this is also A, which means that alternate angles are equal. So they are equal in measure. And so that means that since alternate angles are equal, if this is 55 degrees and this is angle A, and these two angles are alternate angles, which means that they are equal, that means that the size of angle A is going to be equal to 55 degrees. Now let's move on to the next question. Our goal is to determine the size of angle B. Now, in order to do this, what we observe is that this is angle B right here, and angle B is vertically opposite to this angle right here. So that, and one thing about vertically opposite angles are equal. Again, we have that angle B is vertically opposite to this angle, which means that they are the same size. So if this is B, this must also be B as well. And so in order to solve or to determine the size of angle B, we're going to figure out what is this angle first by using this triangle, right? Figuring out what is this size. And then whatever this angle is, that will be the size of angle B because both of them are equal in measure. Okay, so here we use a useful geometrical rule which states that angles in a triangle add up to 180 degrees and that vertically opposite angles are equal. First, we have here B and we have 60 and 55. They should add up to 180 degrees. And so what that means is in order for us to figure out or to determine the size of angle B, we have to take 180 and subtract it with the sum of 60 and 55. So we add them together, then subtract that from 180. So we have 180 minus 60 plus 55, and 60 plus 55 is 115. And so we have 180 minus 115. And so that means that B is going to equal to 65 degrees. And so the size of angle B is 65 degrees. And so this is 65. Let's erase this ink. So this right here is 65 degrees. And because they are vertically opposite, that means that this must also be 65 degrees. And so that means that angle B measures 65 degrees. Next, let's move on to the next question here. Our goal is to determine the size of C. Notice that we have this geometrical rule that we can use, which states that angles on a straight line add up to 180 degrees. Notice that we have angle C here, and we have this, and we have the size of, and we have this angle which measures 65 degrees. So we have angle C and we have this angle whose size is 65 degrees. They are on a straight line, all right? They're on a straight line and they're at a common point. And so what that means is angle C plus 65 degrees should add up to 180 degrees. And so what that means that if we want to figure out the size of angle C, what we need to do is we need to subtract. We need to take 180 minus 65, and 180 minus 65 is going to be 115. And so that means that the size of angle C is going to be 115 degrees. And so that's the measure or the size of angle C, 115 degrees.